Here we are at McConnell Springs Park in Lexington, Kentucky. This is a really cool place. If you go inside, they have all kinds of displays of plants, a knowledge base of all kinds of things about the geology of the park and things of that nature. So the reason we are here is because of the karst. And if you watch the other video, you know what karst is at this point, but it's basically the result of dissolution of limestone. This limestone tends to dissolve fairly quickly in terms of human lifetimes. Over the course of several thousand years, you can go from just a crack in the surface to a cave. So we could talk a lot about the history of the park, and there's actually a sign here that talks about that. That's not why we're here today, but just to give you a quick bit of information, the park was founded in 1775 by a guy by the name of William McConnell, and it was used because of the proximity to the spring. I'll show you that in just a little bit. He used it for refrigeration. It was named after Lexington, Massachusetts. Obviously 1775 was an important time. There was a lot going on then. The park has been bought and sold several times, and it was eventually acquired in 1994, I believe so, by Friends of McConnell Springs, which is a group that helps take care of this springs. This is a city park. Lots of cool things to see here. Obviously, we're here for the geology, but if you'd like to visit the area, or maybe you have, you can learn about all kinds of other things, including the history, the biology. There's a really old tree here. I think it's over 250 years old, called the bur oak tree, and it's extremely huge. And from my understanding, the reason that's the case is because of the type of landscape that we have here, which is a part of this class. You know, physical geography and geology is all about landscapes. So the landscape we're going to be focusing on today is karst landscapes. So I'm going to pause. I'm going to take a short walk, maybe 1/10 of a mile or so down this way, and we'll reconvene there. All right, here we are. This is referred to as the Blue Hole. Here's a park visitor. And there are signs like this all over the place that were created by a variety of organizations. But the Blue Hole is an interesting feature. It's a karst spring, and I will post a paper that some students and I wrote about it in the comments of the YouTube video if you want to know more information about it. But this is a karst spring. Karst springs are often quite large compared to other types of springs. And again, when we say karst, as mentioned in the other video, we're talking about dissolution of limestone, things like caves, sinking streams, karst springs, and things of that nature. So I've seen this spring actually up probably as high as up in this area. And this is referred to as the Blue Hole because it's been measured down as far as 15 feet, and it has a blue tint to it because of its depth. And the reason this is the case is under Lexington, under certain parts of Lexington, we have karst topography. So the entire, basically, I don't want to use the word entire, but a large part of the southwestern region of Lexington is drained and comes up through this spring. A number of dye traces have been done, and they conclude the same thing. Again, I'll post that in the chat. And some students and I from Eastern Kentucky University, UK, and Northern Kentucky University have done our own studies here, not only to measure that, but to measure the amount of time it takes to go from one sinkhole to another. So there is a large sinkhole to the south of here, about a mile and a half. I don't remember the exact distance, but we put dye in there, and it showed up in this spring in a number of hours. So even though it's traveling over a fairly large distance, it can get here pretty quickly. And the reason that's the case, in karst geology, it's basically like a series of not man-made, just a series of natural plumbing tubes under the Earth's surface that's a function of, that's created by the dissolution of limestone over a long period of time, over several thousand years. And that's what happened here in in McConnell Springs at Blue Hole. So here's the first part of Blue Hole. I'm just going to walk down the way a little bit, and it flows over here. Here's a cool diagram that shows actually where we are. It's a good way to orient ourselves. So here's Blue Hole on the left. It comes up here out of nowhere. It doesn't surface anywhere else other than over a mile south of here. It flows to the left to about 100 feet. I'll show you where it sinks again in just a second. It flows beneath the surface in this karst topography, these series of underground dissolution features. And then it resurfaces at a place called the Boils, which I'll show you in a bit. And it flows above ground for about half a mile, and then it goes into the final sink. And this is the final sink here at McConnell Springs. It resurfaces again at a place called Preston Cave Springs, which you may see if you read the report. All right. Just going to follow it down the way here. It's a really neat place. Very peaceful. There's not a lot of people here this evening. Here's the final sink. We're in what we refer to as low flow conditions, meaning it hasn't rained in a while. The creeks and rivers are not very full, but you may be able to zoom in a little bit here and see it's sinking over here in this corner area, right over in here. So when we did our dye trace study, measuring not only where the water is going, but how long it takes to get there, we put these little what are referred to as charcoal dye receptors in the corner, and we had an auto sampler testing on a minute-by-minute basis as to when that dye arrives and how fast it's going and that sort of thing. So you can't really see the actual sinkhole from here. You can actually see it better than you usually can because the conditions are so low flow, but it is right in that area. Up ahead, in between Blue Hole and the Boils, is what we refer to as a karst window. There's a little pathway over here where people have been walking. But what a karst window is basically a depression in the surface, or a little bit of a sinkhole that shows you, in this case, a small sinkhole that shows you down into the surface, and during high flow conditions you can see how water has been in here. So this is just a segment along the way between the 2 points I mentioned earlier where water flows. All right, we're going to walk on down to the Boils, which is pretty close by. The Boils is not referred to as the Boils because of temperature. We don't have hot springs in this part of the world. The temperature here, as you may recall if you watched some of the other videos, is around 54 to 55 degrees Fahrenheit year-round. Why is that? Because that's the temperature of ambient groundwater at this latitude in Lexington, Kentucky. Now, if you were to go up to Canada in a cave, or water flowing out of a cave, or down to Florida, those temperatures are obviously going to be quite different. But here in Kentucky at this latitude, it's about 54, 55 degrees Fahrenheit. All right, so this is the Boils. It flowed underground for, not sure exactly how many feet, but let's say 1,000, just guessing. And it comes up here. So obviously very low flow conditions at this time, but I've been here in the past when water has shot up out of this due to hydraulic pressure, due to hydraulic head, as we call it in geology, and it shoots up maybe a foot or more. So this is referred to as the Boils. I'm going to show you the geologic diagram here. We are here. And you may, if you're reading this, you may notice the word artesian in the second paragraph there. And that's kind of unusual in this region of the world. And what artesian means is that it flows up, it shoots up out of the ground under pressure. So we don't see that a whole lot around here. So this place is pretty unique and pretty neat because of that. All right, we're going to take a bit of a walk, and this stream flows above ground until you get to the next stop, which is Final Sink. And I'll turn the camera off and we will turn it back on when we get to Final Sink. All right, we're approaching Final Sink. The park, I apologize, I'm breathing a little bit heavily because I walked up here. But look, it looks like the park has recently built some new stairs and a new deck to overlook Final Sink. It's pretty neat. So I don't have a whole lot to add at this point, but this is just connecting the last place we visited, the Boils. This is looking upstream toward the Boils. Here's the stream. And here is Final Sink. So the water is flowing down into that sinkhole, or swallet, as some people might call it. And that's the last you see of the stream. It doesn't resurface again until close to a mile away to the west of here at a place called Preston's Cave Springs. We won't visit Preston's Cave Springs today, it's getting late, but if you're interested in knowing more about it for whatever reason, if you happen to have visited here or curious about the area, like I said earlier, I will post more information about some studies that some students and I have done in this area. I was actually surprised when I started doing research on areas to do this type of study around here. Not many people have studied this region. People have studied it in other fields, but not in terms of groundwater flow and those sorts of things. So we wanted to shore that up and put it all into one document or two. So that will conclude our quick field trip of McConnell Springs here in Lexington, Kentucky. If you have any questions, feel free to send them to me and I'll be happy to try and answer them. One last quick stop this is the bur oak. That's apparently over 250 years old. Very large tree, as you can see.